In this video, we will be presenting about applications of differentiation. So, what is differentiation? Differentiation is a mathematical theory on finding the derivative or rate of change of a function. The rate of change of a function can define as dy over dx is equal to function of x is equal to y. What is the applications of differentiation? There are 5, which is related rates, maximum and minimum, Rolle's theorem, mean and value theorem, and to determine increasing and decreasing of a function. What is related rates? Related rates are rates of change associated with two or more related quantities that are changing over time. For example, a spherical ball is being filled with air. Both the radius and the volume of the ball are increasing. Arguably, the rate of change in the volume, which is V, is related to the rate of change in the volume. In this case, dV over dt and dr over dt are related rates because V is related to R. Why do we use related rates? Related rates are often used in calculus to solve problems using the derivative of the sum and difference, solve problems involving product function, which we will use product rule, and solve problems involving rational functions, which we will use quotient rule. Related rates are also used in other aspects of life, such as real-world application, for example, how fast a balloon inflates, understanding interdependence, which can lead to a better prediction, and also critical thinking and problem solving. In conclusion, related rates are used to quantify and understand change in interconnected variables over time, which make it crucial not only in mathematics but also in other fields.
Next, let's look for the problem statement. Water is pouring into a conical pile so that the height of the pile is always equal to twice of its radius. If the water is pouring at the rate of 12 cubic centimeter per second, how fast is the height of the pile increasing when the pile is 6 centimeter deep? Now let's look for the solution for the question. Step first, we need to identify the information that has been given in the question. So, we have been given dV over dt is equal to 12 cubic centimeter per second and h is equal to 2r. And we need to find dh over dt when h is equal to 6 centimeter. Now, as we know that volume of cone is equal to 1 over 3 pi r squared h. Next, for the second step, we need to express r in terms of h to find dh over dt. H is equal to 2r and we get r is equal to h over 2. And then for the step 3, we need to substitute the r into v formula, which is v is equal to 1 over 3 pi h over 2 squared h. And then we get v is equal to 1 over 3 pi h cubed over 4. And then for the step 4, we need to differentiate v, which is dv over dt is equal to d over dt in bracket pi h cubed over 12. And then by using chain rule, we get dv over dt is equal to pi over 12 and then in the bracket times 3h squared dh over dt. And then we get dv over dt pi over 4h squared dh over dt. And then for the last step, we need to find dh over dt using given information, which is they gave us h is equal to 6 centimeter and then dv over dt is equal to 12 cubic centimeter per second. And then we just substitute and then we just need to substitute the information given into the formula. that we have differentiate just now, which is 12 is equal to pi over 4 times 6 squared dh over dt, and then we get 12 9 pi dh over dt, and then we simplify it into to get dh over dt is equal 4 over 3 pi centimeter per second.
For summary, by identifying the right formula and steps to solve the problems for first and second derivative correctly, we can conclude that the applications of differentiation can be used to define values of the given problems.